Good afternoon, everyone. Today we are going to continue with the unit number 4, that is IoT protocols and security. In the last session, we have discussed about the IEEE 802.15.4 protocol. Then we have discussed about the Modbus protocol. Now, in today's session, we are going to discuss about the Bacnet protocol. Okay, so the Bacnet, it stands for Building Automation and Control Networks. Building Automation and Control Networks. So it is developed by the American Society for Heating, Refrigerating and Air Conditioning Engineers. Okay, this is the association. By this association, this Bacnet protocol was designed. Okay, so it is a data communication protocol. This protocol is designed for communication between buildings or communication between building automated system components, that we are going to build a component, automated system components. So to make happen the connection or the communication between these two automated components, we are going to use the Bacnet protocol. Okay, so this Bacnet protocol, it is, yes, so this Bacnet protocol is an object oriented protocol. Okay, so it is an object oriented protocol which views its implementation in the form of objects. Like if it is an object oriented protocol, that means we are having the objects for communication. Here objects means your physical devices, temperature inputs, that means your analog input, or your relay control, that is your binary outputs. Okay, so there are different Bacnet objects are there. Like Bacnet object is a logical representation of your usable entity. That usable entity can be your physical objects or your physical device. Okay, that physical device, or it may be your temperature input, that means your analog input or your binary output. Okay, so this Bacnet currently having 30 object types. Okay, so some of them like access door, calendar, device, file, binary input, binary output, or binary value. Okay, so it also provides different services to perform like read, write, and IO operations. Okay, so Bacnet objects are evaluated and controlled by their properties. Their different properties are there with their values for the Bacnet objects. Like object is having their type, their present value, status flags, out of service status, then inactive text or active text. Okay, so these are the properties of this object, and having the values like object name is your lightning area, sorry, it's an object. Then having the type like binary out, and its present value is it's active, and status flags, see the normal and in service. This is the status flags of that object. Okay, so these are the what we can say the property name and its values are there. Okay, so this Bacnets having different objects, as we have seen that, like objects like access door, calendar, device, file, binary input, binary output, or your binary values, or analog input or analog output, also with the analog values. Okay, so these are the different Bacnet objects. Okay, so your devices means all physical devices that needs to be implement. Okay, that needs to implement the device object, that will be your physical devices. And files means your, or that file provides some file objects, or it provides some file services to access that file object. Okay, that means it provides some file services to access that file object. Okay, so these are the some Bacnet objects are there. And similarly, that it's having some properties. Bacnet is also having some properties, like object is having object identifier, object is having object name and their type. Okay, so these are the three properties for this particular object, or that properties may vary based on the specification of that object. Okay, so these three basic properties are there, like object identifier, object name, and object type. Okay, so Bacnet also provides some services. Okay, so services means your actions that can be performed with the help of that Bacnet objects. Okay, so Bacnet services means like actions that are performed by using the Bacnet objects. So these services are formal requests that one Bacnet device sends to another. Like you can say that it's a client server it behaves like, or it follows the client server model for communication. Like server sends some instructions, or we can say server provides services to the different objects, and that client will, or that objects will access the services from the server. Okay, so it behaves like the client server model. So these are the services. There are different services are provided by the Bacnet, or the Bacnet class. Okay, so that services like your object access service, then your alarm and event services are there, file access services are there, then remote device management services are there, and your virtual terminal services are there. So these are the 5 services that are provided by the Bacnet class services. Okay, so these are the different 5 services are there. So first one is your object access services. So this object access services is it is a set of services that provides or it provides the access to the objects by using the services like read property, write property, okay, create property. So these are the different services are there, like for the accessing this object, or we can read, or we can write, or we can create a new object, or we can delete the object. Okay, so these are the services for that particular object. And second one is alarm and event services. Okay, so it provides an event reporting to various activities. Like alarm, we can set the alarm for the change of any event values. Okay, so for that it uses the alarms and change of state. Okay, that changes of states will give the alarm for that particular event. Okay, so there are different services are there for this alarm and event services, like acknowledge alarm, confirm, unconfirm, okay, get alarm, get event information services. So these are the different services for this alarm and event. Okay, the next one is your file access. So for file access, so we can perform a read or write operation on the files, okay, by using the services like data, or we can transfer the data, or we can train the data. That means only one operation is performed at a time. Okay, so we can at a time we can read the data, or we can write the data. Okay, then next one is your remote device management service. So this remote device management services means it is used to identify object. That means here you can see this who is or I am service. Okay, that means this service is used for to identify the objects over the Bacnet network, or we can by using these services we can start and stop the messages remotely. Okay, so that means we are going to access this objects by using, or we can access this object remotely using this remote device management. We are going to manage this object remotely. Okay, or we are going to start or stop the messages by using remote device management. And fifth one is your virtual terminal. So it allows the bidirectional exchange of character, or character, or what we can say this just a minute. Okay, so virtual terminal means it allows the bidirectional exchange of character oriented data streams. Okay, so these are the 5 services that are provided by the Bacnet class, okay, or Bacnet object. Okay, so see the Bacnet protocol stack. Here you can see the OSS stack is there. In that we are having the 4 layers. Like first we are having the physical, then data link layer, and network layer, and the application layer. So Bacnet application layer, you can see this network layer. You know that at the physical layer we are having the devices or the connections like Ethernet here. Okay, and in the second, at the data link layer we are having the protocols are there. Different protocols are there. Okay, then at the network layer we are having the connection between the different devices. At the application layer we are going to access the device. Okay, so this is the basic protocol stack for the Bacnet. Okay, Then there are different backnet network types are there. Here you can see this MSTP is there, PTP is there. Okay, 802 point type 1 is there. Okay, so this means that means the backnet IP. So we can use that backnet IP. Yeah, this backnet IP is used with the existing Ethernet or wireless area network. Okay, see this IP. Okay, then backnet MSTP here. Backnet MSTP is there. So this it uses twisted pair or that twisted pair is having the range of up to 4,000 feet. We can use that twisted pair cable. Okay. Then also we are having the backnet ISO 8820-3. That means we can use different backnet protocols, or we are having different backnet network types with the physical and the data link layer. Okay. Then next protocol is your KNX protocol. That KNX means your Connex Association, or this KNX standardization was formed by the merger of three European companies as well. Okay, so the abbreviation of that KNX is your Connex, or that involve, or that Connex is involved from the EHS, that is European Home System Protocol, and EIB, that is European Installation Bus and Data Bus is there. Okay, so these are the different mergers are there. These are the three mergers are there, or these are the three European companies that are working for the smart automation of homes or buildings. Okay, so this KNX is used for building automation, or it operates on more than one physical layer, like or that KNX is defines communication specification with the various physical mediums are there. That means this physical mediums are at the physical layer, like twisted pair wiring is there, radio, Ethernet, infrared, power line networking is there. Okay, so these are the different operators are there at the physical layer. Okay, so here every unit hookup with the KNX system is smart enough, and it does not rely on the other part. That means these are the independents. Okay, so these KNX devices. So what are the KNX devices are there? Like these are the sensors, actuators, or the system devices. Okay, these are the KNX devices. Okay, then see this KNX device has three modes. So these three modes are like your A mode, E mode, and your S mode. So A mode means your automatic mode. Okay, then E mode means your easy mode, and S means your system mode. So automatic means that configuration, they configure themselves. Okay, that means your automatic mode. And in the easy mode, it is used to configure the network without use of the PC. Okay, so that means an embedded master controller that can be attached to the KNX node. Okay, that means in the easy mode, it requires training to install that KNX protocol. Okay, and third one is your system mode. So that system mode that includes, or that system mode having that means it must be programmed by the specialist. Okay, that means the configuration and the management of KNX device is done in this mode. Okay, configuration and management. That configuration and management is done by the programmer. Okay, these are the three modes for the KNX devices. So there is another mode for this. In that means we can say this another mode is your logical tags. That means in this mode, it defines an additional frame format along with the standard format. Okay, another format is there in that logical tags. The tags also be designed with the geographic specifications. Okay, so basically it's having the three modes, and another mode is your logical tags. The tags is having the geographic specifications. Okay, so this KNX network can be formed with the tree or line and or the star topology. These are the topologies that can be used to form this KNX network. So this can link up to number of devices. See the number of devices that can be linked using this KNX protocol. Okay, for the KNX network. Now see the routing or the KNX telegram frame format. Okay, KNX telegram format is there for the routing of messages. KNX uses telegrams throughout the network of KNX nodes. Okay, so this format is like there are 8 bits for the control. Okay, there are 8 bits for the control, 16 bits for the your source address. Similarly, for the destination address, having the 17 bits. It's for the that one bit is for your parity bit. Okay, at the physical layer. And next one is your routing centers to route that information having the 3 bits. Then length is 3 bit and up data is up to, you can send the data or you can transmit the data up to 16 bytes. Then we are having the parity of 8 bits. Okay, so this telegrams, as this KNX uses the telegrams throughout the network. So these telegrams are transmitted on the physical layer by octet by octet because of 8 bits. Okay, so these telegrams are transmitted on the physical layer octet by octet. So each telegram is acknowledged by the receiver when the telegram is received, and sender waits for the acknowledgement. So acknowledgement is necessary to receive that telegram. If no acknowledgement is there, or if no acknowledgement is received, then telegram is retransmitted up to 3 times. Okay, so this is the format for the routing of this messages of this is the KNX telegram format. Okay, see this control it decides the priority for the acknowledgement. Okay, having the like high priority, low, then alarm is just notifications. Okay, acknowledgement, not acknowledged, or it is busy, sender is busy or not. Okay, acknowledgement for the uh, confirmation of the data. Okay, then not acknowledgement means it will retransmit the data. Then we are having the source address, this destination address. Source address contains the area ID, line ID, bits, device ID. Okay, having that distributes that 16 bits like 4 bits. Okay, then destination address is up to 17 bits. So that 16 bits is with the address, and last 1 bit is for the physical or the logical. Okay, that means that last bit is your for physical or the logical, or the parity bit is there. Okay, so routing a counter uh, is of top, yeah, 3 bits of routing counter. Okay, so it defines the hop count. It's this count is limited to 6 hops. Hops means your devices. Okay, then parity bits, there are 8 parity bits are there, that is used to secure the telegram. Okay, these parity bits are used for the security purpose. Okay, so this is all about the KNX telegram. Okay, we have seen the KNX telegram format and how the KNX is formed. This KNX standardization is for the there are 3 European companies that are grouped together for the that works for the smart automation of homes or buildings. Then this KNX is used for control of building management like lighting, shutters, metering, remote control, HVAC, then refrigerators, washers, dryers, security systems. That we are going to use that we are going to manage this kind of this kind of devices using the KNX. Okay, so there are different advantages are there for this KNX, like it is platform independent, low energy consumption, it is an open standard. So these are the advantages of this KNX protocol. Okay, so this KNX protocol or this KNX device have a functional block that specifies the functionality of the devices. Okay, or the functional blocks are like logical grouping of input, output, and there are different parameters are needed to perform a task. Okay, so this is all about the KNX, and we have seen the Bacnet protocol. Now we are going to move towards the next protocol, that is your Zigbee protocol. Okay, so Zigbee protocol. So this Zigbee protocol resides on the top of physical and MAC layer. This MAC layer is available on the data link layer, or it is a sub layer of the data link layer. We have seen in the last sessions as well. Okay, so this Zigbee protocol or this Zigbee technology, okay, it's having an architecture. It's having a different sub layers are there, like it's having a application support sub layer. Zigbee device objects are there, clusters library are there. Okay, so the see here this Zigbee is built on the IEEE 802.15.4 standard. We have seen that the very last lecture. Okay, that what is that IEEE 802.15.4 standard. Okay, It's for wide personal area network. It is for the WPAN. Okay, IEEE 802.15.4 is your WPAN. Okay, so this Zigbee is built on this protocol. Okay, so this defines physical and MAC layers to handle many devices at low data rates. Okay, so that data rates, or that Zigbee is going to operate at the here with the 868 megahertz. That's for the Europe with the 20 kbps. For the different regions, it's having the range. For the US, for the US, it's having the 40 kbps. For the worldwide, for the entire world, it's having the 250 kbps. Okay, so this Zigbee will operate with this speed. Okay, then it's having a low cost and low powered mesh network. So that mesh network covers the range from 10 to 100 meter. Okay, so we can extend this range by using the or with the help of different routers. Okay, so how we are going to extend that range with the different routers, we will see in the Zigbee architecture. Okay, so see the Zigbee architecture, it consists of three devices in the network layer. The devices are your Zigbee coordinator, Zigbee router, and Zigbee end device. Okay, that is means it's these are the different Zigbee nodes. Okay, that different devices are there in the network layer. Okay, so that means, so first one is your Zigbee coordinator. So you know that every network in this Zigbee must have a coordinator. That coordinator means your root. Every network is having its root. Okay, so that root is going to handle and stores the information and also transmit, or it's going to receive the information. So this is the task of your root. So this Zigbee coordinator, yes, any doubt? Okay, so this Zigbee coordinator is having a root. Okay, so that root is going to or it provides a fully functioning device. Okay, so that Zigbee coordinator can create a network, and also it acts as a PAN network. Okay, or PAN coordinator is there. So we have seen that every network in the Zigbee must have a coordinator. That coordinator means a root, so that it can handle or transmit the information throughout the network. Then next one is your Zigbee router. So this why you know that router is, we are going to use this router for the extending the network. So these are the intermediary devices that can perform or that can permit data to pass to and from the device. Okay, so to pass the data from device to device, we are going to use these routers. Okay, to route that information. And third one is your Zigbee end device, end devices. Okay, so that end devices are nothing but your, like, we are having the limited functionality to communicate with the parent nodes. Okay, so there are some limitations for the end devices, or it has to connect to a network via Zigbee router. Okay, which acts as its parent. So this Zigbee router for the end device, this router will act as a parent for this end device. Okay, so these are the three devices in the network layer for this Zigbee. Okay, now see this Zigbee architecture here. So this red line indicates the wired connection. Okay, this red line indicates the wired connection, and this is a Zigbee coordinator, ZC, Zigbee coordinator. That means your root. Okay, that root is going to handle and control this entire network. Okay, and this blue colors circle indicates the Zigbee routers. These are the Zigbee routers. These three are the routers. Zigbee routers are there, and these are the end devices. Zigbee end devices. These green circles, Zigbee end devices are there. And this dotted line indicates the wireless connection. Okay, that means these devices are connected to this router through the wireless connection. Okay, and this is the existing network. We are having a network, and this is a Zigbee network. Okay, we are having the routers that end devices are connected to this router. Okay, and we are having a router. That router is going to handle this entire network. So this is the simple Zigbee architecture. Okay, now this Zigbee, that architecture, or we are having the various layers, out of which the physical and MAC layers are defined by this WPAN. Okay, 802.15.4. So it's having various layers, out of which we are going to work with the physical and the MAC layer. MAC layer is the sub layer from the data link layer. Okay, so that Zigbee here, see this Zigbee architecture. In that Zigbee, we are having, or that Zigbee has its own network layer and application layer. It's having its own network layer and having its own application layer. Okay, so this, see the physical layer. At the physical layer, it's working on the physical and MAC layer. So this means on the physical layer, it does the modulation and the demodulation of the devices. Then at the MAC layer, this MAC layer is responsible for the reliable transmission of data with the CSMA and CA. That is, okay, we have seen that CSMA, okay, that it works on the physical layer and the MAC layer, and it's having its own network layer. That network layer is for routing of the data, then network configurations and connections and disconnection management. So this is the task of this network layer. Then the application support and application support sub layer. Okay, application support sub layer. What is the task of this application support sub layer? It handles the 64-bit of IEEE to 16-bit of Zigbee address mapping. Okay, so interfaces with the data mapping services. So it's going to handle, or it's going to map the address of like it handles the 64-bit IEEE to 16-bit Zigbee address. Okay, it's going to map that address. Or this application support sublayer, that is APS, it routes the network layer messages to suitable application object. That means each application object is identified by endpoint ID. Okay, every endpoint having its ID, endpoint devices. Okay, or it also maintains a local binding table. Okay, to hold the record of remote nodes to the or the end nodes. Okay, and the application framework, it provides two types of messaging. Application framework, it provides two types of messaging service, like general messaging service and the key value pair. Okay, these are the two services are provided by this application framework. Okay, then this is all about the Zigbee architecture. Okay, now see this Zigbee operating modes. These are the non-beacon and beacon. These are the operating modes of this Zigbee. Okay, so there are different topologies are there for this Zigbee, like star. So there is a one coordinator is responsible for the initiating and managing the devices. That means the star network we are having hub is responsible for the whole entire network. Similarly, it's applicable for this Zigbee topology. And mesh, that means several routers. We have seen that in the architecture, several routers are connected with each other. Okay, and it's follow the cluster tree, where you can see this cluster tree like architecture is there for the Zigbee. Okay, so these are the star, mesh and cluster tree. These are the different topologies for the Zigbee. Okay, now see this frame format for the Zigbee. Okay, this is the frame format. Octets, two octets are there from, or one is for the frame control and two is for the, okay, we are having the source address and the destination address. We are having the radius, then sequence number. Okay, then we are having the payload field, frame payload, then routing fields are there, and we are having the network header and the network payload. Okay, so this is the Zigbee network frame format. So this frame control having the, or this field size is like 8 octet. Field size is in the octet. Okay, so this is the octet. 2, 2, 4, 6, 7, 8. Okay, octets, that means 8 bits. So frame control is having 2 bits, and destination address is up to of like 2 or 8 bits, or source address similarly 2 or 8 bits. Okay, the destination and source address can be up to size 2 or 8 bits. Then radius is up to of 1 bit, sequence number is 1 bit, and payload, the payload. Okay, this frame payload, it can be variable in length. Okay, so frame control bits are used to define various parameters. Okay, various parameters like communication type, the type that communication can be unicast, multicast, or broadcast. Okay, then security enable or disable. The next parameter is like route discovery. It can be enable or route discovery enable or disable. Then source or destination address. It can be already specified or not specified. Okay, that is IEEE address is there. Okay, so this address field can be 2 or 8 octets to handle 16-bit Zigbee address or 64-bit IEEE address. Okay, this source or destination address. That's why it is not specified, or it's having the 2 or 8 octets to handle this 16-bit or 16-bit Zigbee address or 64-bit IEEE address. Then radius. This radius defines maximum number of hops. Hops means your devices. Radius defines maximum number of hops that are allowed for the packet. Okay. Then sequence number. Sequence number is the your packet counter. Okay, we are transmitting information packet to packet. So this means sequence number is your packet counter. Then next field is your payload. Okay, next field is your payload field. Okay, so this payload carries application support sublayer and the network layer. Okay, so this is all about your Zigbee network frame format. Okay, so there are different applications of Zigbee like home automation, smart metering, smart grid monitoring, industrial automations. Okay, so this is we are going to stop here for today's session. We have seen the Zigbee topologies, Zigbee network or Zigbee protocol. Then we have seen the Bacnet protocol and KNX protocol. In this session, we have covered 3 protocols. Okay, on this unit. Okay, we are going to stop here. Thank you. Yes, anybody having any doubt here for these protocols? Yes, anybody having any doubt? Yes, you can ask. If you are having any doubt with these 3 protocols, any part. Okay, so we are going to stop here. Thank you.